Today we're going to talk about functions a little bit more, functions and their graphs, and just to take a preview of what's coming up. Quiz 3 will be a take-home, and I'll give you that on the 19th. We've got another take-home on the 28th. It was planned, that was originally planned to be in class, but that's to make up for the class cancellation. And then test 2 is coming on October 30th. Okay. So that's sort of preview of upcoming events. Okay, so let's just go through the preview exercises together. So I've given you a graph, y equals f of x, and I want to evaluate f of 0. So that 0 in the parentheses, is that an x or a y? X. That number in parentheses is always an x, always an input, always the independent variable. So when I write f of 0, I'm telling you x is 0, you tell me what y is. Okay, so if you look at your graph, can you tell what y is when x is 0? 3. So f of 0 is 3. Okay. And then I want to know for what values of x does f of x equal 0? So now I'm asking you for the x, which means that that 0 that I gave you has to be y. Okay, so you're looking for y coordinates of 0 and the corresponding x coordinates. -3 and 2. Good. So we call -3 and 2 the zeros of the function f, because those are the x values that make f of x equal 0. So we call them zeros. The real zeros are what we have traditionally, before today, we've called them x-intercepts. Now you can also call them zeros. Okay, so identifying the domain and range from a function's graph. So we talked about domain and range last class. Domain was the set of all x values or inputs, and range is the set of all y values or outputs. So domain is sort of all the x's that the graph lives on. Right, so here's my graph. All the x's that it covers are the domain, and all the y's that it covers, right, would be the range. So let's look at an example. I want to find the domain and the range of this function graphed here. So I want all the inputs that the graph lives on, all the x values. So I'm looking at the x-axis. What is the smallest x value where this graph exists? -7. And then it covers every x value moving from left to right. It's continuous. So it covers every x value, and then it just keeps going and going according to that arrow. It just keeps moving right forever. So my domain here would be -7 to infinity. Should I include the -7? Yes, because it's a closed circle there, right? So my domain is -7 to infinity. And then your range, you want to look at the y-axis and look at the smallest and largest y value that this thing covers. So what's the smallest y value on this graph? Y value. -2. Yes, yes. So now I'm looking at the y values. So the lowest one is right here at -3, -2. That's the lowest point. But for range, I'm only listing the y values. Okay, so it's -2. And then what's the largest y value on this graph? Infinity, because again, over here we've got this arrow, so the y values are going to keep going up forever. So you have -2 to infinity. Should I include the -2? Yes, because there's a closed circle there. All right, even and odd functions. An even function is symmetric about the y-axis. So if you have symmetry about the y-axis looks like a mirror, right? Then your function has this property that when you plug in an x and you plug in the opposite of that x, you get the same y value, right? That's what it means, okay? So if I've got my function here, if I put in this x value, if I put in an x value of 2.5, my y value is -14.44. If I put in -2.5, my y value is also negative 14.44. Right? So if I put in a positive 2.5 versus a negative 2.5, my output is the same. All right, and that works no matter what my input and output no matter what input I choose. If I put in a half, my y value looks like 7. I'm just making that up. 1/2. If I put in a half, it looks like my output is about 7. Whereas if I put in negative 1/2, go up to the graph, same y value. Negative 1/2, also 7. So that is how you can check. You can check graphically, does the y-axis look like a mirror? Or you can check algebraically. Does putting in a positive and a negative x value give you the exact same y value? All right, we call that an even function. Okay. So that's called an even function, one that has y-axis symmetry. An odd function has what we call origin symmetry. It's harder to see origin symmetry. So for even symmetry, if you fold over on the y-axis, you can see that the right half would be on top of the left half. Origin symmetry, to visualize it, imagine folding twice, once along the x-axis and then along the y-axis. So you're folding like into quarters. And then the upper right part would be on top of the lower left part. So that's how you see origin symmetry graphically. To see it algebraically, when you plug in an x and the opposite of x, this time you don't get the same y value, you actually get opposite y values. So if I put in 1.28 and go up to the graph, I get a y value of 12.13. But if I put in the opposite of that, negative 1.28, go down to the graph, my y value is now negative 12.13. So this is a little bit different than even symmetry. With even symmetry, I would have put in 1.28 and negative 1.28 and gotten the exact same y value. With origin symmetry, you get the same value, but one's positive and one's negative. So you get opposite y values. So for our conclusion, for an even function, opposite x values give the same y value. In an odd function, opposite x values give opposite y values. Okay, so now there's going to be lots of stuff for you to work through on your own.